In Math 30-2s, we're going to go over our worksheets here. So let's get right at it. So obviously these are the exponential ones. So here's where we get this nice little exponential graph here. It looks like a growth. You can see that's going from left to right. It's going upwards. It doesn't cross the x-axis, so we got this nice little asymptote at the end here. It's got a y-intercept of 1, right? That could be seen from the graph here because the a value, remember exponentials are going to be a to the b to the power of x, right? The a value, as we explored in the lessons, determines where the graph crosses the y-axis. So that's good to know. So let's go down here and let's just state some of the stuff we have here. Number of x-intercepts. That's a common thing between all exponentials in our course, at least, that they have none. Unless you move the graph downwards, then yeah, we don't have any. The y-intercept here, you could just write 1, or you can actually put the point in there, say 0, 1, right? You can determine that from making x equal to 0, right? You can do it that way, or you can just read it right off the graph. It's up to you. End behaviors here. So we're going from quadrant 2 to quadrant 1, right? So that's what's happening there. You always read it from left to right. The domain here, we've got XER, and my range is going to be Y, has to be greater than 0, YER. We're not too concerned about the formal way of writing these with little curly brackets at this point. So it should be good there. So looking at the form, like we said before, if I have y is equal to a bracket b to the power of x, the a is your y-intercept. So I can go through all these and say, oh, that's 10, that's 6, that's 5, and this is 27. That's what I could say. It's pretty easy. I could say that the first two are growth graphs and the second two are decay graphs because of the b values. But I can also say that all of these have no x-intercepts, and all of these go from quadrant 2 to quadrant 1, and all of these have the exact same domain range, right? The only thing that changes for all of these graphs is just the y-intercept. But the last one here, it's not the hardest question. I know we haven't done one like this, but it's just saying that if I put an x value in here, I need to get this y value out. So they just want to solve for what a value would I have to have in this equation here. I know the a is different than the a's above, but this should just be a to the power of x. So if I put a 4 in here, I should get 256 out. Now there's going to be a lot of just, you could just guess check this one, say what number raised to the power of 4 is 256. So you just go in your calculator. Let me just pull my calculator out. Got my phone here. It's fun. It's a little program that you can get on your phone if you want. Now, probably not 5, but let's say 4 to the power of 4. Hey, 256. There we go. So A is going to be 4. Another way to do this is to get rid of the power of 4, you would take a 4th root of this. And because of that, you're going to see that you're going to run into a problem. There's not just going to be 4 in this question. If I do the 4th root, that's under math. There's a math under there. There's a little X root button, number 5. So hit number 5 there. But before you put that down, you're going to have to put you either put a number down. So I can go 4 math X root. So it gives me, and then it'll put a little 4 in that top there where the index is, 256. And I get a 4 out. Okay, pretty good. Now, it gives me a 4, so that's good. So that gives this answer here. But because this is an even index here, you also have that plus and minus idea. Because remember, if I square a number and I get 4, I could square 2 and get 4. That makes sense. But I could also square negative 2 and get 4. So there's 2 answers here. That would give me the solution I need. This, because it's an even root, it's going to have the same. Excuse me. Ooh, face disappeared there for a second. That's going to have the same problem because you have to have the two solutions there. Okay, so let's try this next one out here. If I put in a -2 in there, I should get 2 answers. Now, again, you could just do the same thing. I could take the -2nd root of 64. That's fine. Like, that's something you can do. So I put a little -2 in my calculator. Go math. Number 5 is going to put a little -2 in the index spot there. That's good. And then go math, enter, enter. You get 1/8. I want this a fraction. You put the decimal down because it terminates. That's fine too. I get 1/8. And because it's even, it's a negative even number, you still get the second one. I'm just going to write down here, since -2 is even. Now, the next one here, the value is not even, right? It's odd. And because it's odd, you want to get the one answer. That's it. So I'm going to go 1/216. Now this is essentially all you have to do. There's no weird algebraic thing you do. You can mix things up with the negative exponents and a bunch of other garbage too, but I'm not too concerned about that. Then go -3 math, number 5 there, and take the of my answer. So that's what it looks like there. So 1/20. You can put that all into the underneath the radical too if you wanted to. Just hit enter. You get 6, and there's only one 6. That's it. A is 6, and that's it, because it is an odd number. And we're going to write that down here. Only one solution, since -3 is odd. Right. There you go. Looking pretty good. Hope you got that. Hope you did that. Yeah, question 3 is a bit weird. We never really talked about it in our notes. I keep on finding things like that. I'm like, in our notes. How am I supposed to expect you to do this if we don't do it in class? We don't talk about it in the bell work and stuff. That's okay. So this is just a worksheet anyway. Oh, I'll see you in the next video.